What I've got here is an adaptation of the Blink program. What we've done now is we've added in a LDR, which is a light dependent resistor. An LDR has a changing resistance to charge flow. Increase the light and its resistance decreases. Reduce the light and its resistance increases. So if you notice this circuit here, one end of the LDR is on the 5-volt rail of the Arduino board, and on the other side of the LDR we've connected a 4.7k resistor, and on the back of the resistor that goes back down to ground. If you think about that, that's a voltage divider. So what I've done is I'm just going to take the ground and redraw it so it becomes easier to follow how that circuit operates. So here I've moved it over here. So here's our 5-volt rail, which is on this Arduino, and here is the ground, which is also on the Arduino, but I've drawn it out so it looks like a conventional voltage divider. Now if you're unfamiliar with voltage dividers, have a look at my video, which is called Understanding the Voltage Divider, and have a look at that. That'll help you understand what a voltage divider is, how it works. Now one side of the voltage divider is the LDR, and the other side is the 4.7k resistor. For every coulomb that flows through this voltage divider, 5 joules of energy are going to be released, and part of that energy is going to be released into the LDR, and part of that 5 joules will be used up by the 4.7k resistor. So what we do is we tap off in the middle here, and we want to read the voltage. We want to read what that voltage drop is across there. We'll take the output of that and we'll connect that in to what's called analog input pin 0. Now what that means is this Arduino board then can look at that voltage, and with a piece of code that we'll write in there, it can do stuff knowing what that voltage is. Now if the voltage is high at this point, we're going to decrease the repetitions of the flashing. You don't know how that's going to work until I explain the code, but basically what the code does, it will take, if there's a high voltage, it will make the LDR flash slowly, and if there's a low voltage, it will make the LDR flash fast. So what happens is when the light shines on this LDR, the resistance decreases. Now with a decreased resistance, all the 5 joules per coulomb is going to drop across that 4.7k resistor. If we cover up the LDR with our finger so there's less light getting in, and what happens when we reduce the lights, its resistance increases. Now if its resistance increases, then more of that 5 joules is going to drop across there than across the 4.7. So that voltage there that we're reading across the 4.7k will reduce, so we'll get a lower voltage here. Now with a lower voltage, what do we say? We're going to make this program flash that faster. So what that means is if we move our finger in and out, we're going to see the LED speed up or slow down. So what I've got is, on this side I've actually hooked up the circuit. It's too small for you to see the connections, but I've made these connections. So what I've done is, for the LED, we've got this circuit. The output from the Arduino, pin 13, that's going to be set high or low, so that we get a high voltage or a low voltage. That enables us to switch this LED on and off. So that's down here. For the LDR circuit, so there's our LDR, I don't know if you can see that, but on the other side of the LDR we've got that red lead that goes into the 5-volt rail of the Arduino board, and the other side of the LDR, which is here on the other side of this resistor. We got this resistor here, and the other side of the resistor that goes into ground, as we've shown here, and then of course the tap that comes off the middle, that goes in, that's that blue cable there, that then goes into pin 0, which is the analog pin, the analog block here, and that pin there is pin 0, and that then can be picked up and looked at by the Arduino code. So that's what we'll be doing. So let me just plug that in and just show you how that works before we look at the code to explain how we get it to flash like that. So if I plug that in, now at the moment the LDR's got all the lights shining on it. There's no restricted light on it. Now if I move my finger, as I get closer to the LDR, you'll see that the flashing will increase. There you go. So now we've nearly blocked off all the light completely. If I take it away, it slows down. If I bring it in, There, we cut the light off so it's flashing very fast. Take it away, it slows down. So that's what the Arduino is doing. It picks up that voltage and it does a little bit of code that decides whether it's going to flash it fast or slow, and I'll show you the code now, it'll make more sense. Here's the Arduino sketch, as Arduino likes to call them. We can call them programs, that's what they are really, but the people at Arduino decided to call programs sketches. It's really just the same as the sketch or program that we wrote for the blink. The blinking LED. There's just a very slight modification to it, and that modification is basically this line here, and it's saying that rate equals analog read sensor pin. Now, what's sensor pin? Well, sensor pin, we've also added this line. It says const int, which is an integer, and it's setting the label for this integer to be sensor pin, and it's pin 0. So if we look at the board itself, it'll be the analog pin, that's number 0. So it's going to look at that pin, and whatever's voltage is showing on that pin, it's going to set it to this variable rate. Now, the analog read will take that voltage value, whatever the number is, it's going to set a delay. And as we saw with the blink program, if we increase this delay rate, then the LED will have a slower flashing on and off, and if we decrease the rate, so there's less time between on and off, it's going to flash quicker. So that's all that's happening. What I'm going to do now is use one of the other output pins, and we'll connect to speaker. So instead of the rate activating how fast the LEDs flash on and off, we can actually make the rate make a tone out of the speaker. If it loops around really quickly, then we're going to get a high pitch. If it loops around really slowly, then we get a low pitch noise. So all we got to do now is connect to speaker and play around with some of these numbers, and we'll be able to make a noise, basically, some sort of tone, a high pitch tone or a low pitch tone. So that's what we're going to do, and that makes this very simple program even more interesting. You know, in its simplicity, we can do quite interesting things. So that's the beauty of the Arduino. Very simple, basic programs can do quite cool things for just a few parts. So we'll do that next.